Okay, so this is the video for the solution explanation of classical mechanics 2. And I also upload the PDF as well. So let's start with number 1. Number 1 has 10 points. The question is, does the transverse Doppler effect correspond always blue or redshift? Explain briefly why. The relevant equation is the observed angular frequency is given by the omega s times this relativistic vector. Therefore, angular frequency gets smaller always, and the wavelength becomes always longer. So it's a redshift. Okay. Number 2, we define the Green's function of the Dall'Angevinian operator as the solution of this equation. And this Dall'Angevinian operator has the length, physical unit of length -2 because it's a second order differential. And delta, it's power 4, so it's a length -4. So Green's function has to have a physical unit of length -2. Number 3, for the Coulomb gauge, we are supposed to show that the inner product between the unit vector times wave vector is 0. So you apply this condition of Coulomb gauge and you start with this vector potential in Fourier transformed representation, and you simply calculate this divergence, and then you require that to be 0, and you end up with having this relation. Okay. Number 4, 30 points. You consider an electric dipole with charge Q oscillating with the amplitude A along the z-axis, so that my dipole can be represented like this. And then we assume non-relativist case, and you are asked to compute the radiation in the direction in general, which is given by spherical coordinate. And what you need to compute is the electric field and the angular distribution of the power. So if you take a look at the textbook on page 264 to 265, then you will find, after some calculation, the electric field should be given like this. Most of you got it right, and the angular power spectrum is the one showing here, and most of you also got it right because it was written in textbook. Okay. Number 5, so I wrote a approximate 4-dimensional vector field, potential field, in series of 1/r and higher order, and there are 1 to 3 parts that we need to take care when we make a when we get the electric field. During the class, I mentioned that number 1 and number 3 are order of 1/r power 2, so we don't actually have to worry about. But the number 2 is the one that produces 1/r term, so we have to take into account number 2. All right. The last problem is with 20 points for the electric field of charge in uniform motion, in which direction the magnitude of the electric field becomes maxima and minima, and what's the ratio of maximum to minimum value of electric field for beta around, not around exactly, 0.8. So from the equation 10.88, maxima at this angle because of the sine square term, and minimum at theta is equal to 0 to 2 pi. And if you take a ratio, then all you have to do is to calculate this value. That's 125 divided by 27, which is about less than 5 numerically. All right, so that's it. Thank you.